Today, we will go to finish the compression methods for the image, and we mainly talk regarding the JPG or JPEG format or compression methods that we have in our image. And actually, there is one more lecture that I can share with you. It's about MPEG, but let us see if we have time for the rest of our lectures, then we will do that. Otherwise, we will not have lecture about that MPEG, and I will put it as the extra lecture for you. Then what I will do, maybe I will share that on the MOOC system, that MPEG 1. It's more than our syllabus, but anyway, maybe some of you are interested to know about this video even compression methods and how it will happen for the video part. But it's not really on the main syllabus that we prepare at the first time with each other and we set it. And after this 2 day lecture, from new week, will go for the morphological method, which is one of the important section that we have. And then, as I talked before, that we will talk about object recognition and little bit about color image processing. Maybe the color image processing is more than even object recognition part. Then I think that at that time, all this cycle will be covered, and then we have proper knowledge about this part. Then today talk it's about JPEG compression, and that it's vastly used in image processing. Okay. First of all, JPEG is some standard method which is developed by Joint Photographic Experts Group in 1992, and it's accepted nowadays as the standard and international standard method. This part or this type of the compression method is a lossy image compression, and which will use mainly the DCT, I mean discrete cosine transform methods. Now, because we covered DCT last time, now we have proper knowledge about DCT. This method will allows a trade-off between the storage size and the degree of the compression, which can be adjusted. And mainly, we can say that uh, we have these some chart or some blocks like this. Uh, Even the year that they invent this method is not recent, means that it's around 1992, more than 20 years, 20 to 3 years. But still, this algorithm is valid, and so many researcher as well as product even are conduct based on these compression methods, and they are using that. As you can see here in the block diagram that I bring, we have one image as the input. Then we have the subdivision into the blocks with the size of 8 by 8. Then we have DCT. Uh, on that, quantization and entropy coding, which will happen, and then compressed image will be generated. And then on the other sides, if the image is compressed, then we can have the entropic decoding, then dequantization, and inverse desitting as the reverse back to decompress the image block. This is the methods or the way that we are following. Even today, we split these blocks into the steps. Step one. Some people will say 8 steps, some people say 5 steps. There is no difference because in the step we have the same process that we should do, and we should follow the methods inside the steps. This is more important than number of steps. The next point that I wanted to share with you It's about the fix, little bit fix parts that we have in each step. Even some person say eight step or some person say five steps, but inside of a step, maybe they mix two, three steps in each other. The next thing is that mainly I found some good even resource more than your book, which is the major one. Some white papers and some recent article that I read these weeks to prepare this slide for you, and I use them. I didn't put all the reference there. When I share on the MOOC system, I will put the proper reference for all the papers which I use. I think around 6 or 7 new reference that I use for this 2 day lecture. And mainly what I was search that some new things in the JPEG, if it's happened, then I should introduce today for you. This JPEG is very popular as the data format, but it's not really a data format. And people know it as the compression method. And even there are many compression methods, and JPEG is one of them. But why these methods become this much demand is mainly by the even the good action that it has on the image, and that was the lossy compression methods which use these JPEG. Once more, we can see the process of the JPEG compression method, which will be start from the source image data, and then what will happen on the image. Same as the previous one, we will go to see all this process with two level. One is that some description. Second one, we have some clips that we will see. And third one is some handy example that we will follow all this work. This is nothing more than our main blog because just there was in the book. I copy pasted here for you to become familiar with more with the system. Okay, then as I said, some people say 6 steps, some 5 steps, 6 steps, or 8 steps. But something that we have inside the steps are same, as you can see here. We have the JPEG compression algorithm, which have the uh, 5 main basics. First is that RGB color steps to YCbCr color space conversion, pre-processing of DCT, and then DCT transform as the level of 2, level of 3 and 4. And finally, we have the coefficient quantization and lossless encoding. These are the process that we are searching in this method of compression. And if we follow that, then we can compress the image. Let us see what we have. The first steps that we can follow in JPEG is um, first we should work on the input image. These are all we call it as a pre-processing job or maybe pre uh, processing. What we will do here, suppose in the first one we should after receiving the input image should be divided into some small block, something which may have the 8 by 8 dimension. Why we have 8 by 8? Because this dimension is sum of the 64 units, and each units of image we call it pixel. Then first, as even I bring the Lena picture here, you will see the original image and image splits with 8 by 8 pixel block, which can be do as the first step of our job. Then with the second step, we have the RGB color space to YCbRC color space conversion. In image JPEG compression, first what it does after that 8 by 8 matrix form, we should have this conversion. And digital image, generally they have the RGB color as the red, green, and blue channel. I mean the combination of these channels. Now what we want to convert it to the YCb and CR. What is CR and Y and CB? It's Y is the brightness of the image, CB is the blue differentiate relative to the green color, and CR is the red differentiate relative to the red color. Then first we should put some filter, or we should do some modification or change on our image and convert it with YCbCr. Okay, something like this. JPEG use YCbCr model instead of RGB, and in the second step, it is 8 by 8 pixels or 8 by 8 matrix, which one pixel. This point is important. One pixel in this 8 by 8 is the combination of three components of Y, CB, and CR. Then mm, the MCU that we have can be sampling with the factor of 1, 1, 1, means that these three factors of Y, CB, and CR can be stored in that. Okay, go ahead. And then in the third step, now we are in the border of using the method. The method that we will use is CST, but before doing CST, we should do some pre-processing job or some initial job on our image. What we should do? We should, uh, as you know, DCT is the cosine function. Last lecture I teach you, and does not use some complex number. It converts information which are in the block of pixel from the spatial domains to the frequency domain. Last time we saw this formula in the handy solve question also. I will show you how to use this, but we have the accommodation of the function of fn as the image to some cosine term, and then we should calculate this formula. Then discrete cosine transform act as the part. But before doing that, as we say, some pre-processing we should have, and we will take an energy scale image for our example, for the example that we have, or image that we have. Uh, this form of transformation um, is effectiveness is the 5 steps encoding. And before going to the transform, we will little bit we can talk about this cosine signal, which is lies between 1 and -1, as you can see in this uh, in this figure. Then the next thing that we should see is the quantization as the step number 4, which in that, as you know, humans are unable to see some important aspect of the image because we have that parts have some high frequency which is beyond uh, our limits. I mean the visual limits. Then the matrix after DCT conversion can only preserve value at the lowest frequency that to its certain point. Then we should decrease the high frequency part to the low frequency part that it will be visible for us and we can sense it with the visual system that we have. Then quantization is used to reduce the number of bits per sample. Maybe the act of compression now it will monitor more at how it will sandwich it and put it make it small by the bit per samples and reduce this part. We have two type of quantization. One is that uniform and another one is non-uniform. which the standard formula for that is the rand of FUV divided by QUV, and F prime will be happened by this step. We will see it in the handy question. Step 5, which is a little bit near to end the process of the JPEG or JPEG formats, is the zigzag scan. The zigzag scan will use to map now our 8 by 8 matrix, something like we are sweeping our matrix, and then we will convert it to 1 by 64 vector. Okay. How we will sweep? We will sweep in the form of zigzag. That is why we call it zigzag scan. And this zigzag scanning is used to group the low frequency coefficient to the top level of the vector and the high coefficient to the bottom. To remove the large number of zero in the quantized matrix, the zigzag will be used. Something like the figure that I show you. We have some 8 by 8, then after some processing is the DST pre-processing, and that we will go for the zigzag manner, and by this zigzag manner we will convert it to 64 by 1, and then we will have 1 by 64, means that we can transpose it and have the end product from these steps as the step number 5. For the next step we need the vectoring, which is the different pulse code modulation or DPCM, and applied to the DC component. DC components are large and vary by, but they are usually close to the previous value. And remember that DPCM as the pulse code modulation encodes the difference between the current block and the previous block that we have. Something like this will happen. If you see the figure, we have the 1 by 64, something like array now from our image. But the value, please see the blue part that I mentioned in value are changed, and difference between the current block and previous will be monitored here. Then after this, RLE or round length encoding, we should be act on the array that we have, and to some AC components should come out. This is done because AC components have generally lots of zero values, and it's encoded in the pair of skips and value, in which skip is non-zero value and value is the actual coded value of the non-zero components. As you will see, something like we will summarize some of them, and then we will go for the next part, which again we review before, and that is the DC components, which will be coded by the Huffman. Huffman we saw last time, even we have some proper video how it will act. That in this step, the DC components now will be coded, and then the image can be summarized. Okay. As I said, some people say 5 steps, some people say 8 steps, but the general thing is that after level 6, maybe some of them will compress these steps together. Now we take some initial information about the JPEG algorithm. Let us do it again, review it. Actually, today maybe I will review these steps 2 more times, but in each times that I will review them, I will try to give more example, and then we will consider more point about it. Suppose now let us do some rough step on the image. See what should happen on the image, or what we expect actually for the image before solving the numerical example in that. First, suppose this is the sampling image that we should uh, do the JPEG compression on that. First, as we said, we should cut it or convert it into the 8 by 8 pixel matrix. And let us assume that dimension of our image is something like 240 by 320. It means that the image have 676 1800 pixel, which if we divide this in 64 as the main dimension of the pixel, then we can get around the number of the blocks, something like this. Uh, 64 multiplied by 1200, and which it means that we have 1200 blocks in this image. Okay, if we divide 64,800 by 64 as the total pixel that we need, we now have 1200 blocks. Now your imagination should be something like this, that we convert this image to something like this. Let me see. Yes, this is the 8 by 8 blocks that we have. And then we have 1200 about these blocks. If we take one block from this 8 by 8 matrix, it should be something like this. It's one block which I zoomed, and each size of these pixels. Uh, and now let's talk the zoom blocks in the third column of the 10th row. Is that is the location of this block. Then each 8 by 8 part, or let us say pixel now, the pixel that we can have, it has the value, hmm, uh, which we can simply extract. Even in MATLAB, you can simply extract and takes the value of this 8 by 8 matrix. And this value should be centralized about zero, and it helps the next step. For this, substitute 127 from each. Then the new matrix should be like this. Why 127? We will talk later. Okay. Think that if I want to centralize my value, I should do some action on that. And that is that some fixed number I should remove from that. How I should do, how I should select that number, this is something that we will see in next step. Now, I centralize my matrix, and then DCT transform should act on that. What we do with this transform is that we represent the image pixel with a different cosine wave. And by doing this step, we will eliminate some high frequency in the signal, uh, as we say, to reduce the vision problems of humans, and we want to remove some frequency which really our vision or is not sensitive to that. It is some graphical explanation of this transformation. If we talk about the numerical expression, this transformation create the new matrix that has the value in the left upper corner of the matrix, and other places are almost become near to the zero. Then the new matrix after the transformation will become something like this, which with the help of dct value, it's happened through that. And then we need the coefficient quantization as the next step. That here, with this step, is the values near to zero is will be converted to the zero, and other elements also will be shrink towards the zero. Then each value of the resultant matrix is divided by another matrix which we called a standard JPEG quantization table, and there are two tables for luminance and chrominance components, as we can have here. Then we'll split it into two matrix and two different table of the uh, pixels specification. Then what will happen at the next? It should be the following matrix is the resultant matrix after quantization. As I said, the value near the zero become zero, and the others also will do little bit modification on them to doing the lossless encoding. It can be somehow the final steps, and this method use the Huffman coding, and it's reduced the large amount of memory without losing any detail of image. Most of the time, we will save 70% of memory. Then that is why this method is more effective even these days after 25 years. And what this encoding method does is it gets the frequency of different pixel and store that pixel and frequency instead of storing each pixel. Okay, means that we work with the frequency of the non-visible part. Uh, there is some clips that let me continue the teaching. Then, if we have time, because today Saddam also should talk for us about his project. Uh, I think let me now what we can say. Now let me uh, finish the second part, and then if we have time, we will come back to these clips because this is exactly uh, maybe some process that I tell you, but it's in the cartoon mode. I can share that clip for you even in the mock system if you want. That's better that we will see it later to don't lose the time. Okay, now that was the second time that I reviewed the JPEG conversion methods or compression methods for you. Let us again see it once more. See, suppose I have this matrix as my input image. This image, as we uh, said, should be converted to 8 by 8. And the pixel value in sub image are generally positive, falling in the range of 0 to 255. These pixel values are level shifted to fall in the range of 120 minus 128 to 127 by subtracting 128 from each pixel value. This work will reduce the dynamic range overhead in the DCT processing. Then for the compression standard, the density of the level will be shifted and sub image is taken, and the density coefficient matrix is then quantized by diving the coefficient matrix by quantization matrix. We will have one quantization matrix like this, which on an elements by element basis and rounding the result. Then the quantization matrix is predefined the matrix basing on the DCT coefficient matrix and quantization matrix. We will divide them together, and then we will have the resultant quantized one, which uh, each PQ in this is the rank of the Pij divided by Qij. The elements of the resultant matrix after quantization are recorded in the zigzag manner, starting from the zero frequency elements at the left top most corner of the matrix to the highest frequency elements at the right bottom and most corner of the matrix. This is the zigzag form which will be start. We will start from here, go here, come down, then go up. Again, go there, come down. Go here, come up. And all these elements now we will put in the form of one table, and something like now we will convert to the 1 to 64 elements. The elements of resultant matrix after quantization are recorded in the zigzag manner as it's shown in the figure, which start from the zero frequency element at the left topmost corner of the matrix to the highest frequency elements at the right bottom and most corner of the matrix. This is the process which we will follow for the uh, zigzag manner as the next step. And except of the DC coefficient of the first block, the DC coefficient of the remaining blocks, we will use the DPC encoded, for example, only the difference between the DC coefficient of the successive blocks will be encoded. Since we have many AC coefficient are zero, then we run the RLE at the next part for these jobs to code the counts of the zero efficiency, and the RLE will be stores the escapes and a value. The escape is number of zero coefficient and the value is the next non-zero coefficient. Then finally these RLE are encoded using the entropy coding technique. For example, we'll use the Huffman coding, and in the decoding process, the reverse of above steps are carried out. This will happen after the job. Let us again see this matrix with the 8 by 8 format and sub pixels value with the range of 1, 0 to 255. Then the sub image level will be shifted by subtracting of 128, as we say, from the each pixel value, and the resultant has the pixels value between minus 128 and 127. Now you understand why I say we need to uh, takes the number of 127. Then the DCT coefficient will come to the pictures and act on our sub image. We change the level of them and calculate them. Then the quantization matrix will be considered. Some value like this will happen for us, and the quantized coefficient matrix will be obtained by dividing the coefficient matrix by the quantization matrix and rounding the result on the elements by element basic as we have here. Then the matrix form will come out. What we should do now, next step is that we should go for the zigzag manner, as I say several times in this today lecture. We'll start from the zero frequency, then we'll take 3, then 0, come to minus 3, then go for the 6, then 6 to 2. Like this, we will have this manner till end. And what we will do, we are going to record all these numbers, and as you see, the 63 AC coefficient in the sequence in then run length encoding or RLE will act on them. And the second element is non-zero coefficient in the sequence, and the first is the number of zeros um, preceding. As you will see here, we can have the output after RLE, and this is continued till the last non-zero coefficient in the sequence. Then the run length encoding sequence is ended with the special character that we know EOB. Then what we should do, we should take the difference between the current DC coefficient and DC coefficient of the previous block, which is calculated, the DC difference value and the RLE AC values are then will be entropy coding using the Huffman coding. The DC coefficients and the AC coefficient are categorized with some table like this, as you see. If the DC differentiates falls in the category K, then it's encoded with n plus k bits, and n bit DC differentiate category is based code on k LSBs of its value. If difference is positive, then the k LSB of the value minus 1 if negative. The base code of DC differentiates can be shown in something like the table that we have, and if a non-zero AC coefficient values falls in the category of the k, then it's encoded with n plus k bits with the n bits base code of that. Maybe you now need to review something with the hand to make this process better. I purposefully uh, review this example in 3, 4, 2, 4 uh, to make it more understand for this part. Now, please see, I can have some table like what I show means that JPEG table 3 and which will be counted there. And then, for example, the current DC coefficient is something like DCN, and the coefficient in the table, we can have the coding LSP and MSP part that it can be used for us to calculate and do this compression. But now let us see once more with some handy question, and then see one nice part that I prepared for you. What we learned till now, nothing but just a step of JPEG. Now we are going to follow some uh, handy question. Uh, okay. Can you just tell me that? Can you hear the voice of that person on the clip?
No, sir.
Okay, you cannot. Okay, no problem. I will tell you. Okay, as you will see here, there is the example. Uh, this is the example that now people will do with the hand. Now let us see what we can do. Think that first we will divide by 8 by 8 matrix as the first step. Then first things that we will do is that we should convert the image, whatever image that we have, we should convert it to the matrix. How we will do? It's very simple. MATLAB is capable to do that job. Then now see these numbers as the image. Okay, it's not real number. These are the converted matrix of image. Then what we will do? After that matrix, we will divide it onto the image, onto the 8 by 8. And as you will see, we have 8 by 8 blocks, and each pixel, as she showed there, it contains this value. And pixel range are written there, as you can see. Uh, okay. These are the value of my pixels. Okay. And range also written there. Range of pixel intensities now it's from 0 to 255. Okay, we will change the range between minus 128 to 127. We should put some scale because the reason is that we should compress the file with the help of these methods. Then 0 to 255 as the RGB should come to minus 28 to 27. How? Simple. We should subtract the 128 from each pixel value, which yield the pixel value from minus 28 to 27. And then if you subtract that numbers from 128, you will have these numbers. Then we should complete the formula. This is the DCT formula that we review. If we apply the formula of any of the elements, the results come which will be stored in AI, and then it's a standard matrix that is used for complexity JPEG compression, which is given by a matrix which calls as the Luhmann's matrix, luminance matrix. And this matrix will come out after DCT job. Then if we consider that matrix and that coefficient there, we can apply the formula of round of ij and ik between to the all the members that we have, and then by that the numbers will come out. And you will see that we have lots of zero now here. Now we should perform the tricks or tricks which is done by in JPEG compression in the zigzag movement. Now let us see how that zigzag will happen. Hmm. Now we will see how that zigzag will help us. From here we will start there. See exactly it's like zigzag. See 8 by 8 matrix now should convert with the help of zigzag to 64 by 1. And we will write the matrix numbers with this form there. And you can see that this is the one dimension matrix form data there. And then after this, you can do the RLE. Okay. What I want that you do it once with your hand. It's in your task. But as our aim is to do this job with the help of MATLAB, I prepare some codes for you, okay, which we will see the act of these codes on the image, and I think for the first part of today, then it will be finished. Well, what I've written there, it's the MATLAB code which doing the JPEG job, and this here there it has the good even notation, as you will see. Subtract means that how you should enter the image, subtracting each image pixel by value of 128, how it will do. Then quality matrix formulation that we have here, and a formulation of forward DCT matrix and inverse that we had here, JPEG compression, JPEG encoding, and forward discrete cosine transform, quantization of the DCT coefficient, and JPEG decoding and dequantization of DCT and inverse discrete cosine and conversion of that display of the result will be there. What is the aim? Aim is that when I run the image, I want to have the act on my original image with the help of these. Yes, let us see. With the help of this algorithm. When you run this, first you should say the quantity composition that you need, which quantity you need. Um, Even we will talk later today about this quantity job, but let us see that suppose what will happen if I put something like this, means that the quantity of 60. This is something that I want pointed here exactly in the second lecture. And specifically, you should tell me what will happen with the different number of the quality. Can you see my MATLAB environment now or no?
Yes, sir.
Okay. See, this is your job to tell me what will happen between first image as the original image and compressed image when I change these quality numbers. I put 60 here. Maybe what I want to do, I want to do it with 50. What will happen? I will give you some note, but with this specific program, what will happen? This is the job. And to reduce your job, I will share this code for you now that you can have the proper even code, and even it takes sometimes to manage it better in the way that we want, but that is shared in math work also. Just I do some little modification on that, very small modification on it that no need to to follow. And after do that, I found that okay, people also do the same job, that modification. It takes time, but no problem. Uh, What we will see that we will see the original one and compressed one. I don't know how much you can see, but I can see this compressed one little bit. It did some dark color is not really dark compared to the first one. Maybe it's difficult for you to run it there, but to see it there. But after running, you will understand. I send you the JPEG methods. What we can say, JPEG methods mm, code that you can see. But okay, something that I forget to show you. See, as the first step, what I tell you in the numerical part, I is my uh, image. See, my main image is this. The numbers are here. See, as the image. And what we plan the output should be 1 by 64 or something like this. Let us see what should be the, okay, then this I is little bit different then because now 128 is caught here. You can even see a step by step how we reduce the size and compress it. Suppose I2, yes. I2 is after DCT restarted and K. Yes, this is something like the output that we have, and as you can see, the yes, let me see, yes, 256. Huh, Q50 is the quantity quality what we can say matrix that we had. Then there are some more nice things. Win one, win yes, these are the 8 by 8 matrix that you can see here after cutting the numbers mean that same process that we have, and this is the zigzag block. After doing the zigzag job, this zigzag block will happen here for us, and it's again 8 by 8. And some nice more things that you should see in this. This is the DCT matrix that we described for you. Yes, this is the compressed image. Now, this is my compressed image, C. An original image was I. Can you see? That compressed image will generate based on this matrix. This program is nice. I think we can follow the steps that we had there. Okay, I share the program with you. Please follow that. Even there is one task with this, what we can say, with these codes as well as the steps that we pass. But as little bit short before Saddam make ready, there is something that I will point at here, and I want that you uh, little bit. It's related to the task that we have. This part. It's related to the quality parameter that, as you see, there was one matrix. Meanwhile, of our codes, and you should report me the difference between that. I will give you the task after Saddam's talk. Okay. Now, as you see,
Okay.
I had one matrix that we call it quality parameters. Here, you will see that from the lower compression to the higher compression means that from 58 kbytes to 8K means that higher compression, the difference between the image. If it means that the quality between 1 to 25. Really, in one glance, there is no difference between these two images. But as you see, the size of the image are totally different, and a little bit 8K to 58. 50K is different between them. This much memory you could compromise. This is the beauty of that quality function that we can have in this method. Suppose the result of the JPEG compression of grayscale image Lisa with the 320 by 240 pixel, it's something like that. Original number of bits is this. Compressed number of bits, compressed ratio, CR, NB, and some RMS, which now we don't need. See the difference now. Hmm? The compressed bit number and the other value which will be affected by this quality number. Once more, if you see, suppose the homogeneous 8 by 8 blocks, if we have here, and from the Y image of the Lena, okay, this is the FIG and this is FUV. And a smooth image block, you can see the difference there. Or the quantized coefficient of FUV and dequantization is the different things. It means that as the output that you can see here, the different matrix we generate with the help of this quantization. Reconstructed an original difference that you will see, and you will see the error is little bit low. See, the maximum error that you have here is -6. Okay, between the reconstructed and original one. And another 8 by 8 block of the Y image of Lena between the Fij and FUV. And then again, if we want to show the quantized coefficient and dequantized one, and the finally error, you will see that this error is high now. Okay, what was the difference? Different was from the block that we take. This block was non-homogeneous, and the previous one was the homogeneous block, which it shows something that you will understand exactly in this specific task that I give you. Um, anyway, till now, what we learned was about this JPEG compression. Just if we want to review, let us review it with the form of that clips, and then after that, we waiting for Saddam to uh, start his presentation and tell us about currency detection, which he has done. The project is good. Uh, there are some points even that will bring some good knowledge for you. Let me come back because if I stop the sharing section, maybe it will take more time to return back. Uh, Meanwhile, any question from your side? Any
No,
question?
sir.
Kaya, any question?
Not today, sir.
Moishi, Raunak, I don't know. Hossein, no
Yes,
question?
we are here. No question, sir.
Yes, sir.
Okay. What we learned that was not much more difficult. Now you will see this clip and you will understand that we didn't do nothing today. We just review one nice, what we can say, nice algorithm, and purposefully I share you the codes because I think written that code is not your job. It's little bit need some skill in MATLAB, but anyway, you should now know how to use that. Okay, we have some coding, a specific coding lecture for image processing. I think maybe after 2 3 weeks we will start that. Let us see how time's limit. Okay, this is the image compression methods that they want to discuss for us. This is converting the RGB to UV, UV or YIG. Yes, this is the block diagram of these methods that we know it and we reviewed it 3 times for today. First is that convert RGB to UV, means that from red, green, blue, we will convert to L, C, and chromatic red parts. Yes. Then we need the transformation for that or 3D color space one. Then we have the colors, which as the luminance and chrominance type should come out from them. Step 2, we will dividing 8 by 8 blocks. Hmm. Suppose we have one example. This is the matrix that we have, image matrix from 0 to 255. 128 we will subtract from each pixel. Now we know why, because we want to convert from RGB to the YCbCr. Then it should enter to the CT, DCT, and then take the FUV. Then quantization will come to picture with this formula of round FUV divided by QUV. Then we have table 1 and table 2, which is the default of QUV values obtained from the psychophysical studies, something that we know. Yes. Then we will go for the zigzag order. Then in zigzag, we have DC and AC coefficient. Then we will do the DPCM for that on the DC coefficient. Then RLC will come to pictures for the AC coefficient and run the RLC, run length coding, RLE, and turn it to the 64 vectors. Then the entropy coding will come to pictures. Then JPEG will come to pictures. I think this video was nice to review. Uh, I should talk to Roy that how we can share these for you. But anyway, uh, today talk from my side, it's finished.